And we're live. Hey guys, welcome to
Hello, everyone.
and that's Kyle, my helper tonight, and I'm Matt. From the Perth Observatory. And if you're wondering, what did you get yourself into tonight? Well, you've stumbled into our Perth Observatory live stream. We're going to be showing you some cool stuff through the at the night sky through one of our telescopes. Hello Kyle, how have you been?
Yeah, not too bad. Busy couple of days, but made some time to join in on this live stream.
Good. And we do actually have to thank you to one of our followers here in the Discord chat, Mel's, who came up for the Spring into Milky Way workshop and delivered us some presents for doing this. So thank you very much, Mel. And we're very appreciative. Kyle, you've got to come up and get your presents.
Oh, yes. I've had too many late rotations at the hospital.
Yeah. All right, guys. So tonight, what we're going to do is we're going to. Actually, there's a little problem here. I've got the wrong date in the time here. Let me just fix that for you. Okay. It's the 26th of August. I was wondering when I was going to which live stream I was going to stuff this up. August. All right, so we've got that fixed. Okay, guys. So yeah, what we're going to do tonight is we're going to have a look at some star clusters tonight, and we're also going to have a look at a really cool double star called Alberio, and if we've got time we'll go and have a quick look at the moon as well. If you haven't liked this video already, could you give it a like and also share it with your friends and family? That gives us that allows us to do get more of these and share it out to the people as well. Okay, so what we've got at the moment is we've got Alberio. So we've got the jewel box first up, and so what I'm going to do, this program here is called Backyard Nikon. So we've got the Nikon camera on our telescope, and it was we'll take a photo. So we're going to take a 15-second exposure here at about 5,000 ISO, and yeah. So we've got over here. We've got the control panels here to see what the actual info is that we're doing for the camera. So we've got 80% battery. Now it's going to start taking its photos, and it should come up here very soon. This is a really nice globular cluster that we always like to show during autumn and through to winter time. It's probably going to give its last hurrah. So for this week, there you go, and we'll zoom in on it. So Kyle, what is an open star cluster?
Yeah, I got to say the jewel box is my favorite star cluster.
Yeah. So what's an open star cluster, Kyle?
Oh, after stars in a nebula have all started fusion, and they've got solar wind, and they've blown their initial cocoon of dust and gas away into interstellar space, they can actually still be gravitationally bound together. So all the stars in that center field of view around those six bright stars, they were all formed from the same nebula. So they're like a little family of stars.
Yeah.
And they're all forming around the same time. So I think the jewel box cluster is about 14 million years old or something. So they're really young stars as well. So they may have only just actually blown away their initial cocoon of dust and gas that they formed from.
They were actually discovered by Nicholas de la Caille when he was doing his astrometric observations for his Southern Star Catalogue in 1751 to 1752 in the Cape of Good Hope in South Africa. And if you know your history of people sailing around South Africa, the Cape of Good Hope was anything but good. You did need to have very good hope, and maybe never to buy another lottery ticket, because you would have used all your luck up just getting around there. But it was actually the John Herschel who actually named it the Jewel Box, because he thought this cluster looked like. He said this cluster, though neither a large nor rich one, is yet an extremely brilliant and beautiful object when viewed through an instrument of sufficient aperture to show distinctively the very different colours of its constituent stars, which give it the effect of a superb piece of fancy jewellery. So that's where it got its name, the Jewel Box. And there's about 100 of these stars in the cluster as well. So they are very young, and they're roughly around about 6,500 light years away from us. So we're seeing this as it was 6,500 years ago. So yeah, as we'll when we look through telescopes, you're actually looking back in history. So if you were a planet around one of these stars, probably not enough to form a very nice habitat for you, but you could be, if you're looking back at our sun, you'd be looking back at the sun as it was 6,500 years ago. So yeah, it's so
well before human history.
Yeah, yes, and it's only about it's something like 10 to 20 light years across as well. So it's quite a nice compact. And so this is very close to the Southern Cross. So it's right next to Beta Crucis, which is on the other side of Little Epsilon Crucis and Delta Crucis, and so it's also, you can see it through the binoculars as well. So it's a really easy one to find, and also and you can see here. Right here, there's 3 stars in the middle there. They're unofficially called the traffic lights. As well, so and so you'll see the orange one, which is a star coming towards the end of its life. You've got the white one, and then there's a blue one right here, and so that represents the traffic lights. And so yeah, go ahead.
When we actually look through a telescope at the Perth Observatory, if you do make your way up here at some point, you can actually see with the naked eye differences in those star colors. So it's not just the camera that's doing this. You can actually see with the naked eye, certainly the orange star, and you can see a difference in shade in those 2 stars next to it.
Yeah, and if you go, if it's a really good object. That you can be in the middle of the city and you can still find, you won't be able to see it with and through your own eyes, but if you can roughly find where the Southern Cross is and do it, you should still see a few stars there as well. So it's always a good show as well. All right, so what we'll do is we'll go to another star cluster. So there's all these star clusters that we're gonna. They're getting low in the southwest. So we're going to say like a last hurrah for, at least for this year, because we probably won't be getting. We'll probably have to do live streams at like 4 or 3 o'clock. And
you wouldn't even see him at that point.
Yeah, well, that's it's quite an effort to get out of bed at 3 or 4 in the morning. All right, so I think what we'll do is we'll go to where should we go? We'll go to I think we should go to the Wishing Well cluster, don't you?
Yeah.
Yeah.
That's a good one.
All right. Okay, so... Okay, just putting in the coordinates. And so do you want to give them a little bit of info on the Wishing Well cluster? Everyone make a wish when you see it.
It's another open cluster, quite like the jewel box. It's a little bit closer. It's around 1,300 light years away from us, and it's I'm actually not sure how old it is. I haven't been able to find a good resource with all the ages of these clusters.
Yeah. Let's have a look here.
When you're looking at it, through a telescope, it's like you're looking down into a wishing well. There's like all the bright stars, the bright blue stars, are like little coins at the bottom of the wishing well.
Let's have a look.
So hence the name. And it's also quite near the Southern Cross, if I remember correctly.
Yeah, so it's near the it's around the Carina Nebula. Oh, there we go. That's definitely it. So we're in the right direction. So we'll go back to live view. We'll zoom in as well.
Yeah, there's actually, I think it is quite young because you can still see a little bit of nebulosity in it if you take long exposure pictures.
Yeah.
I'm not sure whether I've imaged this one in particular, but I think I've got it in some of my other wide field pictures. But there's a faint bit of red nebulosity streaking through. I'm not sure whether it's foreground or part of the cluster itself. But
yeah, I've seen
that's leftovers from the actual nebula where this star cluster formed.
Yeah, I've seen some photos, so we're just taking the photo now of it. I've seen some photos, particularly from like Hubble and also the some of the big telescopes in in Chile, and it does have some redness to it. So it does have some nebulosity. So they're fairly young as well. And there's another one that Nicholas de la Caille actually found in his as he was making some references to as he was collecting stars for his catalogue. So here we go. There's actually some really nice. It's got some 7 red giants, 7 red dwarfs. So we've already had stars, 7 stars to go. Yeah, so it's fairly big. So we've got some orange stars here, probably, and so yeah, there's about 150 stars in this cluster, and this is actually fairly close to us. This is just over 1,300 light years away from us. So there's all these little really nice star clusters around the Southern Cross and the Carina Nebula as well. So it's also known as the Pincushion cluster, the Football cluster as well, the Black Arrow cluster as well. So they've got a lot of names for these guys. And
I don't know where the arrow comes from. I can see where Pincushion comes from.
Yeah, and I can see where the football is roughly a football shape as well. So
yeah, if you turn your head and squint, you can see.
Yeah. So this is located in the constellation of Carina. So that's the back of the Argo Navis, which is the ship that the Jason and the Argonauts used to find the Golden Fleece. And so originally it was one massive big constellation, and when they modernized the constellations back in 1920 and they got it down to 88 constellations, they broke it up because it was just way too big. So you've got Vela, which is the sails. Carina is the back of the ship, which I think it's called the stern. I don't know. I'm not good at with my I'm not a sailor. And it looks like we're probably getting some. Hopefully, let us know if the connection's still okay, guys. yeah, it might be an issue with our internet here at the observatory today. And also then there's Puppis, which is the front of the bow of the ship as well. So it is a really nice, another nice star cluster to show as well. And it was actually it's taken the first light taken from the wide field planetary camera on the Hubble Space Telescope was actually in this cluster as well. So it's got some history to it as well. All right, so what we'll do...
Yeah, I think that they were trying to photograph one of the double stars in there to actually test out the resolution of the camera.
Yeah.
To see whether they could properly resolve it.
Yep. And yeah, that led to the dog house for the for NASA with. All right, so what we'll do is now we'll go to the Pearl cluster as well. So it's another little nice one. So we're going to do, so the Pearl cluster is actually NGC 3766. So hopefully,
yep, that's the one.
Yep. Now, if you hear some a dome moving, screeching noise, that's our Millennium Dome moving. We got some trainees training today, so blooding in the fresh blood. Okay, how we doing?
So yeah, I think the Pearl cluster, or as its designation, as we just read out, NGC 3766, that's another really young cluster as well, so quite similar to the Jewel Box, in a similar region as well. So the entire Crux to Carina area of our Milky Way, that's a really massive starburst region. There was lots of star formation going on there, and there's a lot of very very pretty nebula in there as well.
Yeah.
Ooh, but with the full moon coming up, it's a bit difficult to actually resolve these nebula. Even with cameras, sometimes you need to spend a lot of time imaging them.
Yeah. Yep. Again, part of that.
As for the Pearl cluster, again, it's around 14 million years old as well, about 10 light years across.
Yeah.
And again, of a similar distance to away from us as the Jewel Box. It's about 5,500 light years away from us.
Yeah. Yep. Here we go. 15 seconds. So with the camera, what it does is it takes the photo, and then it also takes another. It gets rid of some of the noise out of the. So that's why it really takes 30 seconds instead of 15 seconds. But there's about 137 stars to this cluster when it comes. Here it comes. Just heard the beep in my headphones.
There we go.
Yeah. So right there. So
and you can see, different coloured stars as well. So you've got red giants. We've got main sequence stars. And they're all around the same age, but some of them are burning through their fuel a bit quicker than others.
Yeah, so they've got two, which these two would be the here, this one here, and this one here would be the red supergiants that are there, and there's and the interesting one is this star cluster is coming straight for us at about 14.8 kilometers per second. So imagine going from the Perth Observatory, which is about 35 kilometers east of Perth, about 3 seconds, and within 3 seconds you're in the CBD. So yeah, so there's about 100.
You're breaking up a bit there, Matt.
Oh, am I? I'm breaking up. Oh, damn it. Connection to Central B. Yes, I know it's Roger, one of our volunteers, who you've heard on these live streams. He's making the point that the internet connection seems to be better in the Central Wheat Belt than at the Perth Hills, and unfortunately, yes, that's true. We finally get a clear night, and then we got the NBN causing us issues. But so we got 137 stars to this star cluster as well. So it's these over the next couple of 100 million years, these will all go off in their own directions. These stars, so that it doesn't take a lot for these stars to get kicked out and then go on their own way.
Oh. We've got some action in the Discord. There's some buffering, and apparently there may have been a disconnection.
Yeah, okay. Damn it. Yeah, I think this is our internet issue. Yeah, damn it. Well, hopefully just... Let me just have a look at the speed test.
Connection looking solid, Matt?
Pardon? Yeah, I think it's been the update. That's really bad. Yeah. I think what we'll try and do... How are we going? Is it's first time watching and this same watching. Okay. How are we doing? I wonder... What I'll do is I'll stop presenting as well, and see if that works. Do you mind watching it on watching it on YouTube? Cool.
Yes, all good.
Give me. Roger, Christine told me to make a heckle you, Matt. So the international gives me a reason. Internet connection seems to be coming and going. I think persist with it, Matt. There's only 80% of none. Nothing. Well, cool. Thanks, Roger. Let's have a look. Are we back? Cool. All right, guys. Let us know. I've just restarted the stream. Let me know if you guys if you're able to see it. Seems to be healthy. Excellent connection.
Technical issues, unfortunately.
Better now. Yes. All right. So we're doing 5 frames a second. Thanks. But yeah. So look. Okay. We'll here at Perth Observatory. We're up for a bit of adversary here, and we'll plod along as well. So thanks, guys, for staying along, and thanks for keeping us in the Discord chat, letting us know how we're going here. And guys, if you do have questions, please let us know. Please ask them in the Discord channel, and we'll answer them as well. So, all right. So yeah, so we'll get back. So if you guys haven't seen it, this one here is the Pearl cluster, and this is very, very close to the Carina Nebula that we've shown in previous live streams, and they're all both the Wishing Well and the Pearl Nebula have all formed, roughly formed from actually not the Wishing Well. The Wishing Well was way much closer, but this one's actually formed from the Carina molecular cloud. So this has been roughly formed from the Carina Nebula as well, and so yeah, as I was saying beforehand. Over the next couple, with these open star clusters, over the next couple of 100 million years, they'll kick themselves out over a period of time, and they'll go off in their own direction. So we usually like to say that this is like, for stars, if you're putting it into human age, so anywhere from toddler all the way to high school, where you kick the kids out to go to uni or TAFE and get a job as well. So random. So we've got Charlie saying, random question, but do you think Mars used to have water on it? And look, yeah, it does actually have water. It's underneath this. Most of it's underneath the surface, but you do actually have poles, the North and South Pole, where it does have some of that water locked in. And the good thing is we're coming up to Mars being at opposition. So when Mars is at its closest point and is on the opposite side of the Earth to the Sun, so roughly around about October, it's going to it's going to look really nice in the night sky. So if you go out now, well, not exactly right now, but it's around about 10 p.m., you'll actually be able to see it, and it will be quite noticeable. It'll be very red, and also it'll get brighter and brighter and brighter as well. And so it will be quite noticeable. We'll get phone calls and emails here at the observatory saying, "Hey, what's that? What's that in the night sky in the east?" And like we do with Venus, that's how bright it will be. And thankfully, it'll be coming. Thankfully, it will be coming up in October, because it will be there for November, when we have this massive big patch in the southern hemisphere where there's literally nothing to look at. So it gives us another object. So Charlie was saying, let me rephrase. Do you think it had oceans and lakes? Look, I would say it probably did have lakes and oceans. We can see that there is channels that are caused by running water. So it would be interesting to see whether it did actually have lakes, because oceans, particularly the northern hemisphere, would be one giant ocean. But we have seen from the craters, I think Spirit landed in Gusev Crater, or was that Opportunity?
So, yeah.
There was the one that Opportunity. As it landed in, that they basically, when they talk about the Mars rovers, they talk about how Spirit was the problem child, and Opportunity was the golden child, because Spirit was always all the problems were solved with that came up. All came up on Spirit, because that was the first rover they built, and then they worked out all the issues with that's right. I'm looking at the dome here, so that's why it's all white. But it's so when Opportunity actually landed, it actually it unfurled, and the lander drove out, and it was able to test out. Well, I really don't like that look. It was able to drive out, and its crater, they actually found the evidence of rolling of water that had been going through as a channel. So I would definitely say that, from that kind of stuff, there would actually be lakes and seas as well. So yeah, all right. So Kyle, did you want to just continue answering that?
Some of the later Mars rovers, I think they were meant to be doing a lot of spectroscopic analysis of different minerals, and taking quite deep mineral cores to actually look for evidence of sedimentary rock and clathrates and other sort of water holding minerals, so that they can actually see evidence of long standing large bodies of liquid water on Mars. So I think they've got some circumstantial evidence for lakes and oceans, enough so that we can say that with a decent probability that they were there. But I'm not sure if there's any solid mineral proof of long-standing lakes and oceans.
Yeah. Okay. So I've moved the dome. So hopefully in a couple of seconds, while I take this test shot. Ooh, it's quite close there. To be fair to the Meade 14 tonight, it's actually been behaving relatively well. Let's have a look. Stuff has been fairly close. So we're now moving to what's called 47 Decana. Now this is the second biggest globular cluster. So we've gone from looking...
This is 47 Tuck.
Yeah, it's annoying that it's only slightly... There's no bright stars. That's the good thing with open star clusters, is that you can at least see some bright ones there. Thanks, Billy. It's nice to hear that this is the best thing, especially when we've had some technical issues. Okay, let's do one. Let's have a look. Quick 1 second. You would have thought that some of these would have been viewable in the live view. Oh, cool, so I'm going the right direction. Oh, no. Look. Yep, alright, and then zoom across.
Oh. Alright. Any luck getting it?
Yeah.
There, Matt?
The problem is I'm a perfectionist. Come on.
So we're definitely doing 47 tuck next, right?
Yes, yeah, we've got 47 tucked right now here. So, dropping out in Cal again. Oh yeah, which is really weird. Okay.
Alright.
We'll plot along through this.
There we are.
Yeah. All right. I think if it's
getting there.
All right. Cool. Yeah. It's getting there. Okay. All right. So do another 15 seconds at 5,000. All right. So this is the next one.
Tuck now that we can see a bit more of it.
Yep. Okay. So I'm now taking the shots.
In Discord we are having some dropouts, but
yeah.
let's continue.
Yep. Okay, guys. So the next object that I'm just taking a photo from. What's called. So we've gone from a series of open star clusters to this is now a globular cluster. So we've gone from really young stars to really old stars. So we've shown on a couple of times. Omega Centauri, which is the largest one around the Milky Way, and looks like we had in our shot we've had a little bit of. Actually, I need to. That's me having. We're gonna have to do some focusing here. Damn it! All right. Did you want to explain what the it's 47 tuck is, Kyle?
Yeah, sure.
Cool.
So a globular cluster is pretty much, the name is self-explanatory. It's a globular cluster of stars. And every galaxy has a decent number of these, usually orbiting around the galactic core. These are very, very old stars. The average age of these stars, the estimated age, is 13 billion years old. And that's actually about the same age as our galaxy, maybe even a little bit older. So these globular clusters are like little galaxies in and onto themselves. So I think 47 tuck is around 60 light years across, and it's got, I think,
it's got about 1 to 2 million stars in it.
Yeah, that's right. And it's actually the second brightest globular cluster in our sky after Omega Centauri, like Matt said. And I think it's a pretty one. It's got the core itself is a lot denser, a lot brighter, and I feel you can see a bit more detail, out near the edges of it. So visually, I think it's quite stunning. And it's one of the globular clusters where they've actually looked for black holes, like for black holes close by. So they do that by actually looking at how quickly the stars orbit around the center, and with some fancy math, they've estimated that that 47 tuck might actually contain an intermediate mass black hole that's holding it all together. So it's like a little mini galaxy in and of itself. So yeah, you can see on the image that once focus is all sorted out, that there's that really, really bright core region. That's where all the heavier, brighter stars are orbiting around, and you can see as you go further out to the edges, the populations of stars, it gets a little bit sparser.
Yeah. What you
yeah,
have happen
the
is
vast
you get
majority of those stars around that.
self-migration. So some of the bright stars, they actually some of the bigger stars that form outside, they actually migrate inwards, and they also kick some of the smaller ones outside as well. So the smaller ones that form outside or inside the actual core, they get sent out.
Yeah. And I think 47 Tuc is really interesting scientifically as well, because it's got a really big population of what we call neutron stars. So these stars are stellar remnants from supernova explosions, and these ones in particular are spinning really, really fast. Their orbital period, their rotational period, is in the milliseconds. So they're called millisecond pulsars, and they essentially sweep radio beams due to their intense gravitational and magnetic fields. They throw out a lot of radio waves. So a lot of radio telescopes, when they're pointed into the sky, hear this regular pulsations of radio waves. And for a while, the astronomers thought that it was ET sending a signal, but no, in fact, it was these very massive neutron stars, these stellar remnants, sweeping radio wave beams around, due to their rotational speed.
Yeah. And they're all especially in the center, they're very, very close. They're only about, those stars in the center, you can see how they're overexposed here. That's much better, isn't it? That's those stars in the center there are about 10% of a light year away from us, from each other. So we haven't actually been able to find any planets around these stars. We think maybe because they're Generation 2 stars, there hasn't been a lot of material to be able to make planets. So material around these stars, they're very metal poor stars, so they don't have a lot of oxygen, carbon. They're mainly hydrogen and helium. But yeah, imagine if you were a planet around one of these stars, there just wouldn't be any nighttime. That at best you'd get twilight conditions, just because there'd be so many stars in the night sky. A really good way to think of it, in terms of distances, how much space there is between the stars, is that if you were to shrink the sun to the size of a pool ball or a billiard ball, for more of the culture who play billiards, and if you put that in the center of the CBD here in Perth, if you had another pool ball there to represent the Alpha Centauri system, it would be in Karatha. That's how far away, that's how big space is. So yeah, and you can go out and have a look at Alpha Centauri in the 2 pointers, or it's the brighter one of the 2 pointers that point towards the Southern Cross, and that's how far away the stars are. And it's going to take a decent steps in technology to be able to go to these in a good lifetime. But yeah, so. The biggest one we've actually seen of these is actually around the Andromeda Galaxy, called Merrill 2. It's about 250 light years across, and it has, they think they've got about 20 million stars in that star cluster as well. But here in the Milky Way galaxy, we've got about 120 of them that we officially call. Most of them are above and below the disk of our galaxy. So they think a lot of them were formed from gas clouds that were orbiting around the Milky Way when it was first formed. Because they're about 12. Again, they're 12 billion years old. And so there are a few like Omega Centauri and maybe this one where they think maybe there've been dwarf galaxies that have been consumed by our galaxy. This one's about 16,000 light years away from us as well. So it's actually my little favorite, one of my favorite objects to show on the night sky tours. I prefer this than Omega Centauri because it's a lot more neater. Omega Centauri is all over it's all over the place. This has got a nice ball to it.
It's a messy cluster.
Yeah. All right, so I'm going to now put this onto our star called Alberio. So hopefully, please, for the love of God, does this have this time we're able to easily move to the and have it all focused. So we're going to go star named, and let's have, there it is. Yep, and I want that one, and we're going to go. So this is this actually the star, a double star is actually can be found in the north. So when you go out and look to the north, you'll notice there's a really bright in the early evening. You'll notice there's a really bright star on the in the bottom, and that's Vega. So if you ever watched First Contact or read Carl Sagan's book First Contact, that's the star that they went to. And then there's another quite bright star further up, and that's Altair for the Assassin's Creed lovers. And that forms I think it's called the Spring Triangle, isn't it? Or Winter Triangle that they call it in the northern, the Summer Triangle they call it in the
Summer Triangle.
Yeah, yeah. So did you want to have a chat about that, and I'll get this all set up and take the photo of the star.
So
Thanks.
Alberio is one of the, it's a really nice star to cut your teeth on if you're looking to split double stars, because there's a bright star which is quite yellow-orange, which is the largest star, and a faint companion star which is actually quite well spaced away from it, and that's actually quite a blue star, and even with a decent-sized telescope, you can actually resolve it quite easily, and you can see that quite striking difference in color. So with the actual two stars, it's a really nice star to, again, cut your teeth on splitting double stars, and just having a look. It's a nice object to look at in the sky. It's about how far away is it from us again? 420 light years away, 430 light years away from us, and it's I'm not actually sure how far apart those two stars are. I can't actually rightly recall. But it's not just it's a visual double, but in terms of the actual stars themselves, Alberio A, the brighter yellow star, it's a spectroscopic double. So there's two stars there as well, but we can't actually split them with the naked eye. So so potentially there's actually three stars in that one star named Alberio.
Let's have a look here. Go to live view. Good. They're there. Okay, so we've got them in. Stay on target. Stay on target. Okay.
Stay on target.
Yeah. Alright, I think that's good enough. Okay. So, here we go. Farewell, 47 Tuck. We'll be seeing you on a night sky tour soon enough. Okay. Da, 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 da. We need to have some good, some tense music, while the camera's taking the photo. So that there's actually been a little bit of contrast these two stars, because the data that they're getting back from the Gaia mission, they don't really know if these guys are now actually are orbiting around each other. There's another star we call, which we showed during summer, called, there we go. And it's called Winter Alberio, because it's winter time when it's viewable in the northern hemisphere. And we know that they're just ships passing in the night. The yellow star is actually about 6,000 light years away from us, and the blue star is about it's like the blue star is about 300 light years away from us. And so we know there just happens to be, we're living in the right time to see them close together. But we're now not too sure whether these guys are actually orbiting around a central point. Gaia is a mission that's done by the European Space Agency, and it's rotating around. It's able to take a complete view of the night sky, and I think about a month or so. And I know Steve, who was on not last weekend, last live stream, but the live stream before last. He took a dump of the data dump from the first data that was sent back, and it was 500 gigs, and it's not images, they're text files. And he didn't realize he actually had unlimited download until he was actually halfway through this downloading of the data. So because he wants to be able to go sift through it and find occultations and all that kind of stuff of stars, where one star moves in front of another star, so you can do fancy stuff with that. So now he's got to, when he finds some time, he's got to build the database so he can do his searches through there. But as you can see, this double star is a West Coast supporter. We've got the yellow star and blue star. Now I'm a West Coast supporter, but I'm a West Australian supporter. So for 2 weeks of the minimum 2 weeks of the year, I don't like Fremantle, but it's more important to beat the other states in the AFL. But so yeah, you get some really nice distinct colours here as well, and it's a really nice one to see. And the interesting thing is people see different colours. I've had people say they've seen pink. I've seen some people that see green. Yeah, so it's really interesting that this one to see as well. So actually, they've actually named, the United States Navy named a crater class cargo ship Alberio. So this was one of the Liberty type ships that they that was used in World War II to send cargo to not only Britain but also to the Soviet Union as well. So it's quite interesting to see that they've done some spectrography of Alberio B, and it's rotating. It's a blue companion star. Yeah. And it's rotating at least 250 kilometers per second, and its temperature is about 1302. Just over 13,000 Kelvin as well. So it's a fairly decent star there, and it's in the constellation Cygnus as well. So this is one of the Cygnus is the Swan as well. So it's really a nice. I'm glad it's back up, because we didn't have really a really good. We've had some double stars that we could show on a night sky tour, but they're all the same color. At least with these, they've got different colors. And they've got about a rotational. If they are actually rotating around each other, they're actually they're rotating around the central point at about every 214 years. So yeah, it definitely is one of those ones that if if you're looking to do some night tours and that kind of stuff, or you take your telescope outside and you want to have a look at some objects, Alberio is definitely a one to see. And we can just make it out here with the observatory if you've got good eyes or wearing glasses. But if you go out of the country, out in the country, they can actually, you could easily make it out once you know roughly where it should be. If you use like a app on your phone, or like Stellarium or something like that, you can work out that's one of the brighter ones as well. All right, so I think before we finish, what we'll do is we'll go to the moon as well. So finish off with, consider, we're not always going to have live streams with the moon out. So let's go to solar system objects, and we'll go to the moon. We had a volunteer social night the other night, and after watching Office Space, we ended up watching The Martian, and it was realizing that they haven't actually made Andy Weir's next movie called Artemis. They haven't made a movie out of Andy Weir's next book, which is called Artemis, which is based on the moon. It's a really good book. It's the audio version's done by Rosario Dawson. So, but let's have a look here. Just moving the dome around. But yeah, if you've got if you're looking for a good read, definitely have a try. Have a look for that, or if you've got an Audible account, I definitely recommend spending a credit on there. Can we see it? Whoa, it's very overexposed.
I don't want to hear that you've lost the moon, Matt.
No. What type of an astronomer would I be if I couldn't even find the moon? Boy, that is really, really bright. Let's have a look if I can. Okay, so I go to planetary mode because that's where I can.
It's like half moon tonight.
Yeah.
Planets and gibbous.
Yeah. So we don't need.
Yeah.
Go 400.
Yeah, 400.
Okay, let's get the.
A very short exposure, I think.
Yes. Okay, I'm gonna pull up the. Let's switch over to full screen mode here. There you go. So that way I can work. Where is it? Okay. Let's have a look. So let's drop it down even further. 140. Drop it down a little bit. There you go. And there you go. So here we've got the man on the moon, as we'd see in. So the telescopes flipping the image. So taking we're seeing kind of like what the northern hemisphere people see with the man on the moon. But if you were to go outside with binoculars or so, you'd actually see it flip the other way. So it looks like a bunny. And so this is the head of the bunny, the two ears. So hang on, do it on the. So this is the ear, the head, which is the sea of tranquility. This is the sea of fertility, and this is the sea of nectar, I think it is. And this one here is the sea of serenity. So for all the Seinfeld lovers out there, serenity now. And so we got some nice craters here as well. There we go. And the good thing is we can actually see we've got the Terminator line here. Not that Terminator, but where day becomes night. So we can see along here. We've got some of these craters, and you can actually see that there's shadows in them. So we're getting some definition on the craters as well, and we can see how deep. We can see how deep they are. So the reason they call these dark patches here mares is because they originally thought these were massive big seas, and so what they actually turned out to be were the reason they're dark is because they used to be massive big lava pits, and so you had dark lava that's dried there, and most of it is basalt, but they found it was Apollo 15 where they actually were able to find some of the original crust, which is called an orthosite. If you're able to find it, when they did Apollo 13, when they did the movie Apollo 13, HBO did a 12-part series called From the Earth to the Moon. And in there they talked about one of the episodes there they talk about going out and teaching the astronomers to become geologists as well, and that was Farouk Al-Baz, who was the astronauts called him the king because he came from Egypt. So and so he got his it was actually Harrison Smith, who was also who was one of the actual Apollo 17 astronauts as well, and so Al-Baz was helping them as well as Harrison Smith's lecturer at uni, and those two. So Al-Baz would actually help. While one of the astronauts would fly in the plane, they'd fly over this area which they'd bombed and blew up to the ground to make it look like the Earth, look like the Moon, and they were to fly over and they were to spot the different craters and what could they be seeing. They had to talk about the rocks that they were seeing and all that kind of stuff, and they would go off into the places like Monument Valley or the Grand Canyon and go through and have a look at the different rocks, so that they could learn that once they got there, they could actually be the geologists' eyes back on the ground. And so a lot of these areas that were chosen for the Apollo sites were not only chosen for easy to land, but also to try and find interesting rocks as well. Where did they think they could, by looking at the terrain that they can see from the maps of the moon, and also from the photos that were taken from the Ranger missions, which were basically they fire a satellite to the moon and just take photos until it hits the moon. And then the later survey missions,
I remember that.
they use those to find where they should actually land. So around the Sea of Tranquility, they actually landed Apollo 11 and Apollo 17. I think Apollo 17 was actually around about here, and I think it's a little hard just because it's flipped. I think Apollo 11 landed around here, so it's definitely on the opposite side of the side of Tranquility, which faces to the moon, which we can see. So yeah, all right, guys. Well, I think that's where. Thanks, guys, very much for staying tonight. It's allowing us to do this, and also staying with us through all our internet issues. It's been a testing time, and I hope you guys have enjoyed it as well. We do have a couple of things coming up at the moment. We have Roger, who was on last week and who's been very helpful in the chats. he and I are going to be going up to the northwest. The Gascoyne region for an astronomy night in Gascoyne Junction, and on the way back, we're actually going to stop off in Kalbarri and do a nightscape night at the new Skywalk. And so, if you're interested in booking, you can book on the website, perthobservatory.com.au. We actually just had one of our volunteers, Jeff Scott, go there. Let me just move the image so that you can see. Let's have a look. Oh, it's annoying when. There you go. We'll zoom it a little bit. Where is it? Come on. So I hate it when when technology fails. But let's have a look here. Anyway, so this is some of the shots that he's taken. Sorry, Jeff. And so you can join us, and let's have a look. If I make it bigger, I'm probably just gonna do. Oh no, I'm getting better. I'm getting better here. There we go. And if I there we go. Yeah. Okay. So here we go. So yeah. So we've got here. There's the Skywalk here, and this is some of the shots here that you can see. So you too could actually be learning how to take photos like this with Roger, who's a very good astrophotographer. He's probably blushing right now. He's very modest. And so yeah, so hopefully it's come along, and WA Tourism is promoting the go out to the country while our border's locked, and there's all these fantastic places you can go and see as well. Like I even went on holidays. Surprisingly, I went on holidays last week, and I went down to Mandurah, and there's a Lake Clifton there which has which has thombulites, which are what look like big circular rocks, but they're actually ancient microbial life, and it's a fantastic lake to go and take photos of. I'm just trying to find, getting a shot for you guys so you can have a look. I think this is the one that I wanted to show. So yeah, there you go. So this is the actual zodiacal light that you can see. So this is light that's being reflected back to Earth from the plane of the ecliptic, where the planets all orbit around. And so this is dust and ice particles as well. And so this is the little walkout that you can go out to and have a look. And so yeah, it's definitely one that you could go in the afternoon, bring a picnic along, and then take some photos as well. So this was one I took a 2-minute exposure of the actual creek and got the lights, got the starlight as well from there. So yeah, so it's I was actually quite surprised that the lake was still so clear that you could actually see the stars, and actually the Carina Nebula, which you can see right here. The Carina Nebula was actually in the lake, so it's the very first time I'd actually been able to go out and see those conditions. So there's plenty of places to see. You can go to we've been to Hyden and gone to Wave Rock. That's really beautiful out there. There's if you go to Astrotourism WA .com.au or put that into Google, there's one of our friends, Carol Redford's got this side of trying to get people to go out and do astrophotography and go out to the country and go take a telescope as well. And makes it easy for you. There's a map with all the different sites you can go to. There's Lake Ballard on the way to Kalgoorlie. Southern Cross is amazing. There's no light pollution there. You can go out. Ken Lawson does Astro Tours in Geraldton. There's 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 the Carnarvon Space and Technology Museum up there with the OTC big dish there. That's an amazing place to go and see. If you're lucky, you can go to Carragini as well. So there's plenty of places to go. So while the borders are locked, definitely go out and go to the country. They're really good folk as well. I lived in Northern for 7 years, and it was a great place to grow up. So definitely take on a weekend and go see West Australia. It's an amazing state. It's you've got old English country down and around in Albany. Wheat Belt and up to Geraldton is all really nice pastoral area, and then you can go up and see red dirt and a real amazing scenery up in the north as well. So hopefully you'll it's always an amazing experience to go and see absolutely completely dark skies. It's you'll definitely remember it as well. So thanks very much, guys, for joining us tonight. And if you'd please like and share the video, this live stream. And if you want to keep up with your astronomy knowledge, we've got our Facebook and we're on Twitter as well. And you can see all our cool images that we do for our events on Instagram as well. So thanks very much, guys. Have a great night, and hopefully, fingers crossed, we'll sort out this internet issue next time. Have a great day. Bye. Or have a great night. Bye.